In this video, we're going to look at displaying our data on the high-resolution anatomical. To do this, we need to tackle the problem of co-registration. This is where we look to align our functional data with our anatomical data. To start this process, we want to start with our anatomical file that we've already corrected for inhomogeneities. And then we want to open up our 3D Tools window and go to the Co-registration tab. Here we want to use the option to do FMR VMR co-registration. And the FMR we're looking to open is the one we've already pre-processed. Once open, you can see that it's been overlaid on top of the anatomical in the lower windows, and it's displayed as a transparent blue color. The goal then becomes to align this functional data to our anatomical data. So if we click the Align button, we have a new window. And the process of co-registration involves two steps, an initial alignment step and then a fine-tuning alignment step. If we start with the initial alignment step, you can see Brain Voyager does its best to align the functional data onto the anatomical data. But it's not quite there yet. Next then is the fine-tuning alignment step. This step makes small adjustments to try to best fit the functional data to the anatomical. So far all we've had to do is click a few buttons. The critical part is inspecting the quality of the co-registration. Brain Voyager offers three options to inspect the quality of the alignment. The blend edges option is on by default, and it's worthwhile taking the time to scroll through the brain to make sure the edges of the functional data match up with the edges of the anatomical data. The blend Mosaic option can also be used to better see the functional and anatomical data side by side as alternating squares. During inspection, large anatomical structures are best suited to determine whether or not the alignment was performed correctly. For a closer inspection, you can follow the contours of the grey-white matter boundary. Once we're happy with the alignment, the next step is to close and reopen the inhomogeneity corrected anatomical. Next, we want to click on Analysis, and near the bottom, Create Volume Time Course VTC Data. To create a VTC, we need 5 things. The first is the pre-processed FMR that we want to align to the anatomical. Next is the initial adjustment file that we created during co-registration. And then we want to link the fine adjustment file also created during co-registration. The second last file is the transform file we created to convert the anatomical into ACPC space. And finally we want to link the transform file that converts the ACPC brain into Talerac space. The last thing we have to do is to check the resolution of the VTC we're creating matches the resolution of the FMR. And as a final point, it's always worthwhile to add the resolution of the VTC to the end of the VTC file name. Once the VTC is created, we want to open up our Talerac VMR and go to Analysis and link the VTC at the bottom of the Analysis tab. Once the VTC is linked, we want to make sure the protocol file is attached. If it's not, we want to attach the protocol file. And finally, we want to go back to Analysis and do the General Linear Model single study. Here we define our predictors and run the GLM. Once this is complete, you can see that the statistics from the GLM are overlaid on the volume data in Talerac space. This gives us a much better idea of where in the brain there is activity during our experiment. Like before, we can shift click on a patch of activity on the brain to see the region of interest signal time course window. And we can continue to shift click to add more voxels to the average signal time course.